from the break. So now we're going to take a look at how to query non-relational data in Azure. So let's continue with Module 3. Lesson 3, Manage non-relational data stores in Azure. So when an application writes data, the change is recorded by one server and then propagated to the other servers in the cluster asynchronously. While this strategy helps to minimize latency, it can lead to inconsistencies in the data. For example, application 1 might make changes to a document, and then application 2 reads the same document. But if the application 2 retrieves the data from a different server in the cluster than what application 1 used to write to, there will be a small window of opportunity during which application 2 might see some of the old data. Now, this issue doesn't just arise from multiple applications. Inconsistencies can occur in a single application if a write is directed towards one server in the cluster, but a subsequent read operation is performed against a different server. Now, in Azure Cosmos DB, there are a couple of options that allows you to specify how inconsistencies should be handled. And these options are eventual, consistent prefix, session, bounded staleness, and strong. With eventual, this option is the least consistent. It's based on the situation that we've just described. So changes won't be lost. They'll appear eventually, but they might not appear immediately. Additionally, if an application makes several changes, some of these changes might be immediately visible, but others might be delayed. So the changes could appear out of order. With the consistent prefix option, this option ensures that changes will appear in order, although there may be a bit of a delay before they become visible. And in this period, an application might actually see some of the old data. With the session option, if an application makes a number of changes, they'll all be visible to the application and in order. Other applications may see some of the old data, although any changes will appear in order as they did for consistent prefix. Now, this form of consistency is also sometimes known as read your own write. Bounded staleness is where there's a lag between writing and then reading the updated data. So you typically specify this staleness as a period of time or a sort of window or number of previous versions where this data may be inconsistent. And then with the strong option, this is where all writes are only visible to the client after the changes have been confirmed successfully written to all the replicas. And so this option means that sometimes when your applications are trying to read from some of the replicas, it might be unavailable because some of these changes might actually be trying to be made so that when your application does read the data, it's all consistent. And so eventual consistency provides the lowest latency and the least consistency, while strong consistency results in the highest latency, but it also provides the greatest consistency. And so you should always choose a consistency level or option that balances that performance and requirements that your applications need. Now, although Azure Cosmos DB is described as a NoSQL database management system, the SQL API, the core SQL API, actually enables you to run SQL-like queries against your Cosmos database. So these queries, again, use very similar syntax to SQL, but there are some differences. This is because the data that we're trying to query against your Cosmos DB is actually structured as documents rather than tables. So if we were to use the core SQL API to query documents, the Cosmos DB SQL API supports a dialect of SQL for querying documents using select statements, much similar to the select statements in the relational database. And the SQL API actually returns results in the form of JSON documents rather than the results that you typically see with, or the table rows that you typically see with relational databases. And all these queries must be executed in the context of a single container. Now, just to understand a bit of the core SQL API, we have a select clause. So the select clause starts with the select keyword, followed by a comma-separated list of properties to return. The star usually means all the properties in the document. The from clause, so this clause starts with the keyword from, followed by an identifier, which represents the source of the records. And you can usually use an alias as well to identify where the source is coming from. So in a relational database query, that from clause would typically contain the table name. Now, using the SQL API for Cosmos DB, all the queries are limited to the scope of a container. So the identifier after the from clause would represent the name of the container. The where clause is again another optional clause. So it starts with the keyword where, followed by one or more logical conditions that must be satisfied by a document returned by the query. So you can use the where clause to filter results of some of your Cosmos DB queries. And the order by clause is again an optional clause. So it starts with the phrase order by, followed by one or more properties used to order the output result set. Now, a query can also contain a join clause. So in a relational database management system like Azure SQL database, the join clause is used to connect data from different tables together. In the core SQL API, you typically use the join clause to connect fields in the document with fields in a sub-document that is part of the same document. You can't perform join operations or queries across different documents like you would with the tables in a relational database. So let's go back to our Azure Cosmos DB and our Azure portal, where we've actually imported some of that data into our Cosmos DB, and let's have a look at how we can query some of that data using the core SQL API. So I'm back in my Azure Cosmos DB account. I'm going to go and navigate to that database and container that I created earlier by going to Data Explorer. Now this is going to open up some of the databases that I've created. So the demo database, if I open that up, there's my demo container that I created earlier. So I can come in here and hover over these three buttons, and I'm just going to click and go create a new SQL query. Now by default, it's given me this select all from container statement. So if I executed this, it's actually going to retrieve all the documents that's currently inside this particular container. So I can quickly try and run this. I'll highlight it and execute selection. And as you can see, all the documents inside this container is returned. Now, that's not a very interesting query, so let's do something with it. I know, for example, that this is Volcano data because that's what I imported earlier. So I can drill down into here and look into some of this data with the select all from container statement. So let's have a look at something even more interesting. So if I do a select all from the container and I set a where condition, let me just minimize this a little bit. I've set a where condition, and I know that by looking at this data, there are some fields in my document. So there's a field, for example, like country. So if I wanted to say, for example, specify the country field to be, let's say, Japan. And hit execute. Now, if I pull this up again, and let me just minimize this so that I have more space. I pull this up, now I'm getting all the documents where it contains volcanoes that are located in Japan. So as you can see, I'm still getting a lot of documents back from my container and my query. So let's filter it a little bit more. Now, another field is elevation. So let's see if I can query with country 56 documents, which matches this particular query. So now if I scroll a little bit, I can see that these are all the volcanoes in Japan where its elevation is greater than 1,000. Now let's go ahead and talk a little bit more about some of the aggregate functions that can be used with the Core SQL API as part of the Cosmos DB. So you can use aggregate functions to summarize data and select queries. So you place aggregate functions in the select clause. The Core SQL API query language supports a couple of aggregate functions like count, sum, average, max, and min. So as you can imagine, count is where the function will return a count of the number of instances a particular field in the result set occurs. Sum will return the sum of all the instances of the field in the result set. Average will return the mean value of all the instances of the field in the result set. So the values typically are numeric. And max and min will typically return either the maximum value of the field or the minimum value of the field from the result set. So if we go back to the Azure portal, let's have a look at how we can use some of these aggregate functions to again query our volcano data. So I'm back in my Data Explorer, and now let's use some of those aggregate functions to query our container. So I'm going to use the count one, and I'm going to try and count all the volcanoes in Japan, for example. So let's see what we can do. We can change the star to count everything in the container from the container. And I'm going to leave the condition as country equals to Japan and just remove the elevation. I'm going to then highlight this, and I'm going to execute the query. And we can see that 111 is returned. Now, that doesn't really look nice, so I'm going to give it an alias. So count as total volcanoes in Japan. Let me just run that query again. And now I get the result back that the total number of volcanoes in Japan is 111. Now let's say we want to use a different aggregate function. Maybe, for example, we want to find the deepest volcano in Japan. And so we can use the max function to do that. So let's do and change this to max. And we want to change this to c.elevation. And we'll change the name as well. So this is going to be deepest volcano in Japan. And the from and where condition statement we can leave as is. So I'm just going to highlight this and execute this. And we see that the deepest volcano in Japan has an elevation of 3,776. And these are just some of the ways that you can use the Core SQL API to execute SQL-like queries against your Cosmos DB database. So Azure Blob Storage supports 3 types of blobs, as we already discussed. So block blobs, page blobs, and append blobs. Now, you typically use page blobs to implement virtual disk storage for your Azure virtual machines, for example. They're optimized to support random read and write operations. Append blobs is more suitable for storing data as it grows in chunks. So if you've got log data or archive data, and block blobs are the best to be used for static data, and so they're the most appropriate type for storage that needs to be holding things like image data or video content, for example. So in an Azure Storage account, to store blobs, you would need to create a container. And so this container will group all your related blobs together so that you can organize the blobs in a hierarchy of folders inside that container. So let's go back to our Azure portal and see how we can create a container and upload a blob and also see how we can download that blob as well. So now I'm back in my Azure portal, and what I want to do is create a container in my blob storage and then upload an image. So I'm just going to go into my storage account, and I'm going to find that storage account I created earlier. So if I scroll down a little bit, there it is. Now I'm on the overview page of my storage account, and if I scroll a little bit down, I can see some of the other types of storages under a storage account that you can create. So for example, containers means blob storage, file shares means Azure file storage, tables is where you can create your Azure table storage, and queues is where you can create Azure queue storage. So I'm just going to click into containers. Now I don't have a container set up for my blob storage, so I'm going to go and create one. So I'm just going to go add container, and I'm going to give my container a name. So let's say I wanted to upload some image data to this container. So I'm going to call this images. And then I can also define the access level for this container. So if I hover over this drop down, I can see that there's 3 types of access level I can grant to this container. Private access means no anonymous access at all. Blob access means there is anonymous read access that can be granted for blobs only. And if we set this container to have container level access, that means anonymous read access for both the container and the blobs are allowed. So let's actually stick with private. And I'm going to create the container. Now my container has been successfully created, so I'm just going to go into it. And I'm simply going to upload some image data. So I'm going to go upload. And I'm going to go and select a local file from my desktop or folder. And here you go, I've got some image data here. So I'm just going to pick one at random, and I'm going to pick this one. I'm going to open it, and then I'm just going to upload that to my blob storage container. Now that's been uploaded, so I'm just going to close out of this. And because I've set the container to have private access only, which means there won't be any anonymous access at all. So to be able to access this blob, I would need to get some sort of authenticated or authorized access rights to it. So what I can do is actually I can grab a SAS token, which then gives me a time frame or time period with which I get authenticated access to this particular blob if I can present the SAS token. So if I select this and I come into these 3 buttons here, the 3 buttons here actually, and then I can generate a SAS token from this blob. Now what that means is I can come in here and I can create a shared access signature, so SAS, which will then grant me access to this blob. And so if I scroll down here a little bit, I can assign a couple of permissions. So I can give it read, create, write, delete access. I'm just going to give the read access for now, and I can specify a start and expiry time for when I can actually access this blob. So I'm just going to leave all the default values. I can also choose which protocol to allow, and then I'm just going to hit generate SAS token in URL. And here you go. Now I've got the SAS token, which means if I copy this SAS URL and I go into a new browser, I hit paste and enter, I'm able to grab this particular blob from my storage account. Now let me just close out of this, and I'm going to go back to my container. Now, if you wanted to delete this blob, it's quite simple. We just select the blobs that you want to delete from your blob storage container, and we hit delete. And now because I haven't enabled soft delete, which means when I delete this blob, it's going to be permanent. I can't actually recover it. So I'm just going to go and delete this blob. And there you go. Now my blob has been successfully removed. So you can also use Azure File Storage to store shared files, which means a user that connects to this shared folder or file share can read and write files if they've got the appropriate privileges, that is, in much the same way that they would use a folder on the local machine. Now, to create a file share, we use Azure File Storage under the Azure Storage account, much like the Blob Storage that we saw earlier. And so let's jump it back into the Azure portal to see how we can create a file share under Azure File Storage. So now I'm going to go back out into my storage account. So the same storage account. And I'm going to scroll down a little bit. And so now instead of containers, I'm going to go over to file shares to create my Azure File Storage. I'm going to open that up. And I can just go and create a file share by going add file share. And I need to give my file share a name. So I'm just going to call this my shared files. Now, I also need to allocate a quota to this file share. So I'm just going to say 1 gigabyte. And I can also select the tiers for this file share. So are the files going to be kept in the cool, hot, or transaction optimized tier, or premium tier? So I'm just going to leave the default transaction optimized. And I'm going to come in here and create. And there you go. I've created my Azure file shares. So now that we've created our file share in Azure File Storage, we can use a utility to start copying files over, whether that's from our local desktop or from some other sources. And so we can use a utility tool called AZ Copy to copy files over to our file share in Azure File Storage. So let's head back over to our Azure portal to see how we can do so. So now I'm back in my Azure portal and I've created that file share earlier. So if I scroll down here and have a look, here is my file share called share files that I created earlier. So now what I want to do is I want to generate another SAS or shared access signature token to be able to access that file share so that I can start copying files over. So I'm just going to allow access to files. I'm going to turn all this off, and the resource type, I'm just going to select all of them. Now for this, I can select a couple of permissions. I'm just going to leave the default one that's already chosen for me. And you can configure the start and expiry date time, but I'm just going to leave the ones as is. And then I'm going to generate that SAS and connection key. And now here you go. I've got my file service SAS URL that I can then copy. And now how I'm going to copy over files is I'm actually going to use the Azure Cloud Shell, which contains the AZ Copy utility that I can use copy files over to my file share. So to access the Azure Cloud Shell, I simply need to open up the Azure Cloud Shell from here. Now with the Azure Cloud Shell, it supports both Azure CLI commands as well as Azure PowerShell commands, and you can actually toggle that by changing it over here. But I'm already in the Bash one or the Azure CLI one, so I'm just going to continue using this. Now I need to first upload a file to my Cloud Shell to then copy over to my file share. So I'm going to come into here and I'm just going to upload an image from one of the ones that I've got earlier. So I'm just going to pick the one next to the one that I've already used before, and I'm going to open this one up. Okay, so now I just need to execute the AZ Copy utility to copy over this file that is currently sitting in my Azure Cloud Shell over to my file share. So I'm just going to execute AZ Copy. I'm going to copy over that file, which I've forgotten the name of. So I'm just going to go into my upload files and I'm going to have a look at the name for it. So it's called Windows 1.0 WebP. So let me just put that in. Windows 1.0 WebP. And let me just double check that. So yes, that's correct, because that needs to be important. And then I need to import the file service SAS URL that I copied earlier, because that gives us authenticated access to the file share. So in quotation marks again, I'm going to paste that SAS URL. And now I actually need to make some changes to this SAS URL to specify the file share name as well as the image file to copy over. So I need to actually modify this. So I'm just going to put an end quotation mark here, and I'm going to go up. So this question mark is where the SAS token actually starts. And before that, I need to specify the file share name, which I called shared files, as well as that image that I want to, image file that I want to copy over. So it's called Windows 1.0.webp. And hopefully when I press execute, this is going to then use the AZ copy utility to copy that file from Azure Cloud Shell over to my file share. And now it says the job has been completed. So if I close out of my Azure Cloud Shell, I go back to my file share. I open my shared file share up. And there you go. We see that Windows 1.0 image file has been uploaded to my file share. So this concludes Module 3. I hope you've learned a little bit more about non-relational data services in Azure. So let's go take a 10-minute break. And after the break, we're going to start exploring Module 4.